So the great thing about knowing about the constellations is just how useful it can be in a fun way in your own life when you go outside after dark and you look up into the sky and you see these patterns, and you might know something about the stories that they came from, or you might know something um, about the actual astronomy that's going on, and so you can apply this stuff to your own life. So you're going to need a piece of paper, and we're going to set it up like this. The top half, you're going to take notes up there. You're going to put a title on it. The bottom half, divide it into 4 zones. And in those zones, we're just going to be drawing the different constellations like this as we go. You don't need to do this one right now. Just set up your paper with 4 zones on the bottom, top half blank. On the back, you'll divide it into 8 zones. So, the constellations themselves um, are basically connect the dot patterns that people see in the sky and that have been passed on from generation to generation over centuries. And for example, here's a map of the winter sky in the northern hemisphere. And you might recognize right here is the Big Dipper, part of a larger constellation called Ursa Major, the Great Bear. Over here is the Little Dipper, and this is the North Star. So we're going to talk about how you find the North Star so you can navigate. You can use that to figure out which direction is north. Down here, you might know the constellation Orion, the Hunter. Here's his belt. Now, this line is what we call the celestial equator, and it's an imaginary line in the sky that is formed by extending the Earth's equator out into space. So you can see that Orion is right on the equator. His belt is right on the equator, which means we only see Orion in the wintertime when the Earth is tilted at the right angle for us to look down in that direction. We see Orion. Right now, Orion is setting about the same time that the sun sets. So we don't really see him. We won't really see him for another 6 months or so. There's another line on here labeled as the ecliptic. And look at the constellations that are along the ecliptic: Leo, Cancer, Gemini, Taurus, Aries, Pisces. Are you noticing that these are all the zodiac sign constellations? And this is where we get our zodiac signs from, is they are constellations found on the ecliptic. The ecliptic itself is the path that the sun traces through the sky. So if you were to draw a map of the sun and where it was every day during a year, it would be moving along the ecliptic here, little by little. So the ecliptic is the sun's path through the sky during a year. And these zodiac constellations, the idea is that if your birthday, the sun, let me back up, the sun is aligned with that sign on your birthday. So if you're a Cancer, that means the sun was somewhere in this region on the ecliptic on your birthday. And if you're a Gemini, the sun was over here. Now this means you cannot see your zodiac sign on your birthday because the sun is lined up with it at that time. But you can see it like 6 months later when we've orbited around to the opposite side of the sun. So we're going to take a look at not all of these, but the brightest and perhaps the most important constellations for us in the Northern Hemisphere. So these are the notes we're going to take. Right now, we just want to do these first 3 bullets, and you can, paraphrase these as needed. So the ancient constellations were these groups of stars that seemed to form shapes in the sky. And people are really good at making patterns of things. We see shapes in the clouds, like, oh, maybe we see an elephant floating by in the cloud. Or maybe we see a face in a pattern of wood on the floor. We're really good at making patterns out of things that aren't really those things, right? And so people have done this throughout time and across the world to describe these patterns they saw in the stars in the sky. And of course, different cultures would have different patterns that they saw, and usually the patterns would be associated with some kind of story. So, for instance, Hercules. There is a constellation named for Hercules. Um, so, those are the ancient constellations. Now, modern constellations, and I mean the official modern ones described by astronomers, what they've done is they've taken these ancient ones, and instead of just being a pattern of stars, it's a whole region of the sky, and it usually surrounds an ancient constellation. So there is a constellation for Orion in the modern version, but it's not limited to the stars that make up the pattern of Orion the Hunter. It's the whole region around it. And then an astronomer might describe an object that is somewhere in that region, like the Orion Nebula is within that constellation. Most of the constellations in the northern sky use the ancient Greek names, but the Greeks didn't have names for the southern stars because they never went there. Um, so these constellations were mostly described by European sailors when they first went down there in the 15th and 16th centuries. And some of these are named not so much after mythology like the northern stars are, but more, they're often named after inventions of the time. Like there's one that is the air pump. Somebody first figured out how to make a compressed air pump, and they named a constellation after that in the southern sky. And the third thing for us to talk about before we start looking at the individual constellations, we'll come back to these other three, are asterisms. So this is basically also a constellation, but it's not an official constellation. The Big Dipper is an asterism, which is part of a larger constellation called Ursa Major, the Great Bear. So an asterism is unofficial. They're often well known to people. Like if we talk about Orion's belt, it's just one part of the constellation Orion. Or sometimes an asterism might combine more than one constellation. Like we're going to talk about the the Summer Triangle in a little bit. And it is not a constellation. It's an asterism that is the brightest star, making a triangle pattern of 3 different constellations. So those are asterisms. So when I talk about regions of the sky, let's look at those regions of the sky. Here's a map showing the southern constellations and the northern constellations. So these are the ones we're mostly familiar with. Here's the Big Dipper upside down right now. That's an asterism that's part of this bigger constellation of the Great Bear. Here's Orion right on the horizon. So again, we only see Orion in the wintertime, really. And it's right there above the equator. As we move further south, these are ones that we don't really see very much. Like here's a well-known constellation, a very bright but small group of 4 stars making the Southern Cross. Now let's think about the constellations in 3 dimensions. So here's the Earth surrounded by stars in all directions. And so this globe is kind of demonstrating where the constellations would be. In a way, it's better than a map like this one because this is flat. But this one, we can see that this spherical shape and what's going on here. So here's the celestial equator. right? An extension into space of the Earth's equator. And similarly, we can extend the poles of the Earth out into space. And it just turns out that the North Star is right there, right at the pole, right straight above the North Pole of the Earth, in a line, almost perfect, not quite, but almost, is the North Star, Polaris. And we're going to talk about that in a minute. The southern pole also can be extended out into space, although there is no star that makes up a south star like we have the North Star. But just keep in mind, all this is three-dimensional. And these constellations, when we see a group of stars, they're not necessarily close to one another. They just are in a line from our viewpoint. So anywhere else in the universe, you would not see that same arrangement of stars. Orion is not really a bunch of stars close together. They're just lined up from our viewpoint in that part of the sky. So here are the modern constellations. So let's find the Big Dipper up here. Like I said, it's part of a bigger constellation called Ursa Major. That means the Great Bear. Here's its back legs and its front legs and its head. But notice that it's contained within this kind of weird shape. And this is all considered by astronomers to be part of Ursa Major. So something over here, that red spot, is considered to be part of the Ursa Major constellation. Something down here is part of Leo the Lion, part of that constellation. Here's a map showing all the constellations. All 88 of them are shown here. Here's Ursa Major. Big Dipper is in there. Here's Draco the dragon, Cygnus the swan, Pegasus. And notice here we have all the zodiac signs: Aquarius, Capricorn, Sagittarius, Scorpio, Libra, Virgo, etc., all along the path of the sun through the sky, the ecliptic. Here's Orion, just below the ecliptic. Okay, so our first constellation that we're going to draw down in that bottom half of your paper is Orion. And here's a really nice photo of Orion in the night sky. We can see the most famous part, Orion's belt. And we see his feet. And up here we see his shoulders. There's another star up here that makes up his head. We can also see that this one is a red giant star. You can tell that its color is a little different. We can also tell something's going on right there. That is the Orion Nebula that we talked about another day when we were learning about star life cycles. So when you draw Orion, here's more of it. Let's skip the arms, but like he's raising his sword up here and he's got a shield over here. But I'd like you to label one of those boxes as Orion. And then we're going to draw his feet, draw his belt, draw his shoulders, and his head. And then I think it would be nice if you also labeled the location of the Orion Nebula right where the arrow is. So the two stars that are labeled, I don't think you need to label those either. These are the Arabic names of these stars, just like we use the Greek constellations, we use the Arabic star names, at least for bright stars. So this bright one down at his foot is Rigel, and it's a blue giant, very hot, burning fast and young. Betelgeuse, on the other hand, this shoulder over here is an old star towards the end of its life cycle. It's a red giant fading away. So you're going to draw Orion. Here's a artist conception. He's got the stars of his belt. Instead of his feet, they're showing these stars as his knees. They're showing the Orion Nebula in his sheath for his sword here. He's got these stars for his shoulders. That one would be Betelgeuse. And then he's got this star for his head. He's got a shield. He's lifting his sword. So this is kind of what the ancients were thinking about when they named this star grouping Orion the Hunter. So here's another view. And if you didn't finish drawing, you can just finish from this one. Here's his belt. Here's where the nebula is. Instead of standing, he's kneeling in this view. So we want to include those, and we want to include his shoulders and his head. So basically, you just need this shape on your paper. Now, Orion the Hunter was accompanied by two dogs, the big dog, Canis Major, and the little dog, Canis Minor. Sirius is this star, the brightest star in the sky. And it is also known as the dog star. And the ancient people used to think that in the summertime, its heat added to the heat of the sun, and it gave rise to our saying the dog days of summer, because the sun is in this region of the sky, not exactly here, but it's nearby here during the summertime. Here's another view of it. Orion, basically like an hourglass shape, right? But there's his head. And there's his sword. I like this because it's kind of a photo that of the actual sky that they drew on. So here's Sirius, the brightest star in the sky. It's like the fourth brightest object in the sky after the sun, the moon, and Venus. Then comes Sirius. Now that's a pretty weird looking dog, isn't it? So I wonder if we can get a better image of what Canis Major was looking like when those people were imagining it. Here's another way to think of it. Here's Sirius, this bright star, and then we have these other parts of the constellation. Notice that these stars all have a Greek letter next to them: beta, alpha, theta, pi, and the astronomers have labeled these stars in order of brightness according to the Greek alphabet, which goes alpha, beta, gamma, delta, etc. So Sirius is Alpha Canis Major, the brightest star in Canis Major. Mirzam, Beta Canis Major. So only the brightest of these stars have Arabic names, because the other ones would need to be visualized with a telescope. Here's another view of Sirius and Canis Major. So we could think of it like that. Okay, let's go back to our notes, and that was just an introduction to a constellation and what we're going to be doing. We're going to be looking at them, how they seem in the sky, what they look like to an artist, and doing a quick sketch of them. So right now I'd like you to add this to your notes about the circumpolar constellations. We take the constellations and divide them into three groups: those that are around the pole, circumpolar. So there's two groups of circumpolar constellations. There's the northern and the southern groups. We're only going to look at the northern ones since that's where we live. Basically, these are constellations above the pole. And these are visible during all seasons as they circle around that pole. So what I mean by the celestial pole is the pole in space, an imaginary extension of Earth's axis, and it almost hits Polaris, which is also known as the North Star because of this. So we're just writing this one bullet point right now, and you don't have to write everything on there. Just give it a quick summary. And this paper with your diagrams will be submitted for points when you're done. Right now we're going to look at a few of the circumpolar constellations, and then we'll move on to these other guys. At the very end, I'm going to post this again in case you didn't have time to write down what you wanted to write down. But at this point, I'm going to move on to look at three of the primary circumpolar constellations. So here's what we actually see at night, right? We see a sky filled with these little dots of light. Can you make out perhaps one of the most famous constellations of all, just above tree line, going from here to about here? Can you see that? Can you find that constellation for yourself? Do you see it right here? Hopefully you're recognizing the Big Dipper, right? So here's the Big Dipper, part of a larger constellation called the Great Bear. Um, Incidentally, we can think of it as the handle and the bowl of the dipper. Not all people thought of it this way. The English thought it was a plow. So the blade of the plow that would cut into the soil was over here, and this would be the handle that the farmer would be using to push it through the dirt. There was also a pair of horses or a single mule or whatever would be pulling this thing. So it's also known as the plow. This star right here, can you see that's a double star, properly called a binary star? So the next time you see the Big Dipper, you can test your vision. This is a classic test of vision. If you can actually see that this is two stars, then you have good vision. For a lot of people, the light from these two stars kind of fades together and we only see one star. But this is what we call a visual binary, where it's a double star that we can actually see the two stars with the naked eye, at least if you have good vision. So let's go ahead and draw the Big Dipper on your paper. The Big Dipper, you'll see it at different angles. Like sometimes it'll be at this angle, and sometimes it'll be at this angle. Sometimes it'll be completely upside down. So I don't really care what angle you draw it at. At any rate, this is more than just the Big Dipper, right? This is all of Ursa Major. So here's the bear's nose and head and body, its front legs and its back legs. And what we see as the handle of the Dipper, some people say, oh, that's the tail of the bear. But wait a minute, bears don't have long tails. Well, as a result of that, what do I want to say? Anomaly, some cultures have an explanation of how the bear lost its tail, and that's part of their story of the Big Dipper. It would be how it lost this tail. In Native Americans, at least some tribes, they also saw this as a bear. Kind of interesting that they also saw this as a bear, but instead of a long tail, these were three hunters following the bear. So there's different stories that we would have to describe these patterns we see in the sky. Here's another view of it. Now it's facing a different direction, huh? And here's a painting showing the bear and the long tail of the bear. Now, the Big Dipper is an important constellation for us because it's, first of all, pretty recognizable and easy to find, but then it's also useful for helping us find other stars, as we'll see in a minute. But we got to keep in mind that the stars are not sitting in one place. They are moving through space, and so are we. And as a result, what we see as a constellation today, which is this column, basically 2,000 years after Christ, what we see today is not what they were like in the past, and it's not what they will be like in the future. So here we have 50,000 years ago, 50,000 years before the Common Era is what this stands for. This designation, before the Common Era and Common Era, is used to avoid favoring any one religious group over another. So 50,000 BCE, the Big Dipper would have looked like this, Orion would have looked like this. Today, basically 2000 after Christ, or 2000 in the Common Era, the Big Dipper looks like this and Orion looks like this. But 50,000 years in the future, these stars are going to continue to move, and 100,000 years in the future, the pattern will be completely changed like that. It looks like the belt is going to stick around though, huh? So these stars are moving through space, and the patterns that we see today have not always been there and won't be in the future either. All right, moving on. Now this is the Little Dipper. So this is a new drawing for you. And what you'll notice about the Little Dipper, it also has like the bowl and the handle, but this handle is bent a different direction. And this is an important star for us up here, the North Star, Polaris. It's almost perfectly at the north celestial pole, but not quite right. Now, as the Earth is spinning on its axis, this is the point directly above where it's spinning, directly above the North Pole at the tip of the axis. But just like a top that is spinning, and that top is often wobbling, this point actually changes through time. So what is now the North Celestial Pole won't be in the future and wasn't in the past, but it's a cycle, so it will be again. This will actually wobble along a circular path, and every 27,000 years it makes this cycle of this circle. So where our axis points wobbles, and it's a 27,000 year cycle for this to change. And right now it's close to Polaris, but it isn't always. You don't have to label all of these star names, these Arabic names, don't bother with those, but do label Polaris and maybe put in parentheses it's the North Star. And what we mean by that is it's at the North Pole. It's almost perfectly there, and you can use it to find north, to navigate. You can use Polaris, and this is how you do that. It's easy to find the Big Dipper, so you start by finding the Big Dipper. Now, Polaris, the North Star, is not very bright. It's bright enough to be seen naked eye, but it's not really a very bright star in itself. So instead of finding it right away, we find the Big Dipper, and then we connect the dots between these two stars, and we extend that line out until it bumps into Polaris. That's how you find north. Wait, to find north from there, you drop a line straight down to the horizon. So this is north. So if you're out at night and you're just curious about what direction is north, or maybe you're hiking and you want to find your way around, find the Big Dipper, follow them to Polaris, and then drop a line down here. The Big Dipper won't always be here. It might be over here or over here, but it will always point at Polaris. And Polaris will always be over north. I think it's kind of cool the way it looks like the two dippers are pouring into each other. This one's liquid is falling into the Big Dipper right now. So here's what I was talking about, how the Big Dipper is at different locations around Polaris. But because of our rotation, it spins around Polaris every day. And it also is in a different part of this cycle with the different seasons. So because of rotation of the Earth, the Big Dipper is spinning around Polaris daily. And during the summer, it's like upside down from our viewpoint. In the fall, it's sideways. In the winter, it's low in the sky, pointing up at Polaris. And right now in the spring, it's sideways like this. So we have this movement. In fact, all the stars appear to be moving around Polaris. It's not that they're moving, it's that we're moving though, right? We're spinning around on our axis, rotating every day. And if you set up a camera to do a time-lapse photo, this is what you get. So Polaris is right here in the center. It's not quite perfect. It's right there. Here's another star. See this white line? So this person, they set up their camera on a tripod and they opened the camera lens for about an hour. And during that hour, Earth rotated, and so this star appeared to move along this line. This star moved along this line. This star moved along this line, and so forth. Here's a very red star that moved along that line. And as a result, we get these star trails all forming a circle around Polaris. This is almost like, imagine if this was like a long tube, a long tunnel that you're looking up into the sky. What you're doing is you're looking up to the North Pole. The axis of the Earth is up that tube. Okay, so Big Dipper, Little Dipper, with the pointer stars showing us the location of Polaris. Here's some of the other circumpolar stars and constellations. Draco the Dragon, Cephas the king, Cassiopeia the queen, and Perseus the hero. We're going to take a quick look at Cassiopeia because she's easy to find and pretty bright. So here she is, basically forming a W shape in the sky, or sometimes it looks more like an M, depending on what season it is and what time of night it is. So let's do a diagram of Cassiopeia, the queen. And in some ways, this is not so much showing her as it is showing her throne. So here she is, sitting on her throne. She's also known as the vain queen, so you see she's looking at herself in the mirror. So Cassiopeia, the W, can also be used to find the Little Dipper. Here she looks like an M instead of a W, but the W opens up towards the North Star. So if you can't see the Big Dipper, maybe there's a mountain coming up and blocking off your view right here, but you can see Cassiopeia because you know this M shape or W shape, if it's upside down, you can follow that to the North Star as well. Okay, well, the Big Dipper can also be used to find other stars. So instead of following these pointer stars to Polaris, the North Star, what happens if we follow the curve of the handle? Well, if we follow that curve, it takes us to this star, which they misspelled, which is Arcturus. So there's a little saying, arc to Arcturus. And that helps you find this star, which is part of a constellation called the Herdsman. So you arc to Arcturus, but you can go even beyond that and continue that arc to Arcturus and speed on to Spica. Spica is part of Virgo, the constellation Virgo. Here's another view of this. Here's the Big Dipper. If you went this way, you'd go to Polaris, the North Star, but if we follow the handle, we can arc to Arcturus, which is part of the Herdsman, which today people think is shaped like an ice cream cone. And then there's two different ways to memorize this. I like the saying arc to Arcturus and speed on to Spica. Some people prefer spike to Spica. And Spica is the brightest star in the constellation Virgo. So this is just demonstrating how you can use these constellations to find your way around the sky and find other constellations. Once you get oriented with the Big Dipper, then you can find these other things. Okay, that takes care of circumpolar. Let's write down a couple notes about zodiacal constellations. So these are the constellations that are part of the zodiac. And of course, this has been used for the last several thousand years to create horoscopes. And they are defined because they're located on the ecliptic. That's the path of the sun through the sky. All the zodiac signs are on the ecliptic. Your personal zodiac sign is the one that would be lined up with the sun on your birthday, which means you couldn't actually see your constellation on your birthday because it's lined up with the sun, and the sun is way too bright to see the stars that are beyond it. So you have to wait like 6 months from your birthday to look for your zodiac sign. Now, here's another interesting thing. So these zodiac signs were first developed by the ancient Egyptians, like 2000 BC, 4000 BC, way long ago. Let's just say 5,000 years ago. And remember I was talking about how the Earth's axis wobbles like a spinning top. We spin once a day, but that spinning is slowly wobbling in a 27,000 year cycle. And that means the North Star won't always be the North Star. Well, it also means that the location of the sun on the ecliptic is wobbling. And the 5,000 years that have passed since the time of the Egyptians first designing the zodiac system, well, because of that, actually the sun does not line up with your zodiac sign anymore. It's like a month off. So for instance, I'm a Libra, but really the sun was in Libra, won't be in the sun won't actually be lined up with Libra for a month after my birthday. On my birthday, the sign was lined up with Virgo. So doesn't that mean I should actually be a Virgo? At any rate, um, they haven't made that adjustment, and so horoscopes are still designed to predict your personality based on where the sun would have been about 5,000 years ago on your birthday. Okay, so let's look at some of these zodiacal constellations. Some are easier to find than others, like Libra is very hard to find, so we're not going to look at it. We're only going to look at the brightest ones that are easy to find. I just want to remind you again, here's the ecliptic, the path of the sun through the sky, and all these yellow constellations are the zodiac constellations. I can recognize this as Gemini, and I can recognize this as Taurus, and here's Pisces. It's just because I've looked at these patterns enough to be able to recognize them. And so that's what I'm trying to do for you guys today, is introduce you to these patterns so you can start to recognize them too. So we're going to start with this one. And this is, again, what it actually looks like in the sky. And this is Leo. First thing to look for with Leo is this backwards question mark. Do you see that question mark? So on your paper, you're going to draw Leo. And I'd start with a backwards question mark. And then we've got these other three bright stars back here. So here's Leo's tail. Here's Leo's body. And I think of Leo the lion as lying down. So here's this big cat lying down, but it's holding its head up straight. And this backwards question mark is the arc of its mane. So here's the mane of the lion. And really, it's looking out this direction, but there are no stars marking the front of its face. So it takes a little imagination, I know. Here's a diagram of it that you can use to draw on your paper. So again, we have the backwards question mark. This is Leo's head up here. It's just the front of the head is not marked by any stars. And I think he's lying down, and his body is here with his tail back there. Leo the lion. Here's an artist representation. Standing. I see it lying down myself, but that's okay. So do you see the backwards question mark right here? Forming the mane. And then here's those other three stars we were adding in to make up the rest of the constellation so that the whole thing ends up looking like that. This is a very bright star right here called Regulus. A blue giant right there at his heart. Okay, so that's Leo the lion. Next we have Gemini, the twins. We're going to simplify our drawing beyond what this shows, but you can start by drawing the two twin stars, Castor and Pollux, the brightest stars of the twins. So, and you can see by the stick figures that they kind of look like two people, like arm in arm here. Castor and Pollux, the twins of Gemini. So this is more what I see when I look at it. I basically see a rectangle when I look up in the sky. These two are very bright, Castor and Pollux. They're easy to find. Down here, the feet are pretty easy to find also. And then there's just a couple of other stars along the way that we don't need to worry about too much. If you see a rectangle in the sky with two really bright ones, that's going to be Gemini. Here they are. This is what it actually looks like. Castor and Pollux. You can tell one's a blue star and one's a red star, reddish yellow. Here's their feet way down here. And that's all you really need to draw on your diagram. Their heads, their feet, and maybe a couple others to fill in the rectangle. Gemini, the twins. There they are. So hopefully you're starting to get a better picture of how the ancients came up with these names for these star patterns in the sky. Let's see, next we have Taurus. Oh, another view of Gemini. And this is about as big as it would be in the sky. It takes up a fair amount of space, literally. Okay, yeah, next is Taurus. So Taurus is right next to Orion. So next winter, when we can see Orion, you can also find Taurus. Basically, you follow Orion's belt in this direction, and it should point to the Eye of the Bull, Aldebaran. Now, the Eye of the Bull is actually part of a bigger star cluster, and it kind of makes this V shape, maybe a triangle shape, but it's easier to see it as a V. And notice that the constellation only really includes the front of the bull. It's not the entire bull, but it's got his face here. And then it has a bright star at the tip of each horn. We're not going to worry about these ones. We're also not going to worry about this, except I do want you to draw that. I'll show you why in a minute. So here we go. So we're going to draw the Hyades. The Hyades make up the face of the bull. And this is a star cluster. If you look at this with binoculars, you're going to see dozens and dozens of stars in here. The brightest one, Aldebaran, is the Arabic name for the eye of the bull. So I would like you to draw the Hyades star cluster and then include the horns coming way up here. We're going to skip these guys. And you don't have to draw this line, but where the heart of the bull would be, here's the very famous Pleiades star cluster, also known as the Seven Sisters. It's a beautiful, tight cluster of stars. The Hyades is more of an open cluster, more spread out, but the Pleiades are packed together. Another test of vision is to see if you can see all seven sisters in the Pleiades. So again, all we're drawing for Taurus are these stars making up the Hyades, the horns, and the Pleiades. Let's take another look at the Pleiades. Closer look at the, oh, first, what does this really look like in the sky? Well, here it is. Do you see this kind of V shape? That's the face of the bull, with this brightest star being its eye, Aldebaran. And then if we extend this V outward, we hit these two stars, which are its horns. So it's the face of the bull, and then at its heart we have the Pleiades star cluster. So let's zoom in on that. It's pretty well known. It's a very beautiful cluster, and these are young, hot blue stars burning up really fast. And you can see they're surrounded by gases left over from the nebula in which they formed. This one labels the seven sisters. If you can see all seven naked eye, you have really good vision. It's not too hard to see these five, almost like a mini dipper. But then separating these two out is kind of hard, and separating these two out is very difficult. So here's the seven sisters of the Pleiades, or maybe you speak Japanese, in which case you wouldn't call it Pleiades, you would call it Subaru. That's right. Subaru means Pleiades, and that's why they use this as their logo. Okay, moving on. Now we have Scorpio. So what we're going to draw here is this kind of curving arc of stars, and then it comes up to the brightest star here of Antares, and then it comes up to these stars. So this is the Scorpion, and as you can see by the background, it's found in line with the Milky Way. This one you can see in the summertime, and it's in the south. In fact, sailors used Antares to help them find south. It's a little less reliable than the North Star because throughout the night it moves across the sky, but it's always in the southern sky. Its name, Antares, basically means anti-Aries because it's a red star, They thought of the Greek god of war, Ares. Just like Mars is the Roman god of war, Ares is the Greek god of war, and this is the opposite of Mars, in other words, Antares, anti-Ares. Here's another view showing how it's a scorpion. So we have these stars arcing around here. This is its tail with its stinger down there at the bottom. And then these are forming its body. Here's Antares at the tip of its body, or maybe that's its eye if we shrink this down. And I like the way they showed this, kind of like the claws of the scorpion. And here it is without any hints of what it looks like. So here we go. It's curling around here. Here's the tail, curling around. Here's the bright Antares, and then its claws are going to be up here with the Milky Way visible in the background. Okay, that does it for Scorpio. Next, I think the last one of our zodiacal constellations, Sagittarius. And this is a pretty complex shape, but we're going to simplify it down to just this part here, which is easier for us to find in the sky than the rest of it. And this part right here, as you'll see, looks a bit like a teapot. So that's what you can draw for Sagittarius, is just the teapot. We don't need these other parts, don't need the teaspoon. Now, the cool thing about Sagittarius, also visible in the summer sky in the south, it's right next to Scorpio, is this is the direction of the center of the Milky Way. So the center of our galaxy is over here. We're way out on the edge of the galaxy, and we see it all the way around us, but the center of it is in this direction. And there's a variety of interesting things to be seen. Here's a couple of nebulae, if you have a telescope, that you could look for near Sagittarius. And again, all we're going to draw is this teapot. Keep that shape in mind as we look at these other images of Sagittarius. So here's more of the constellation, right? But can you make out the teapot right here? Here's the spout. Here's the lid. Here's the handle. Right? So this is Sagittarius. Here's the center of the Milky Way, the very core of our galaxy. We think there's a supermassive black hole in there. We think that every galaxy has a supermassive black hole at its core. Here's another view of Sagittarius, the archer, right? So here's his bow and his legs and so forth. But the teapot is still here. Here's the lid. Here's the spout. Here's the body of the pot. And here's the handle right there. So here's the teapot within Sagittarius. That would be an asterism. I like this picture because it's got some nice labels of some of the objects that are in this direction of the sky. Really rich area to look at in a telescope. So we have several nebulae that we can look at. Oh, this is the Eagle Nebula. That's the one with the pillars of creation that have become famous from Hubble photos. And then we have a series of star clusters. And these are like, imagine a sphere of stars that there's like 10,000 stars packed together in this small space. And when you look at them in binoculars, you're not going to see all 10,000, but you can see dozens and dozens and dozens of stars packed together in a circular area right here, or here, or here. Center of the Milky Way, right off the tip of the teapot. So when you're out camping this summer, look for Sagittarius in the southern sky. Then get out binoculars and look for some of those clusters. The nebula, you would need a telescope to see those. But these star clusters, you can see those with binoculars. Now, here it is without any hints. It's much harder to make out at this point, isn't it? I think it's actually easier to make out um, when you're looking at the sky than with this time-lapse photo, because it's picked up so much light that we're picking up a lot of faint stars that make it a little harder to see. But to me, I think this is the spout of the teapot right here. And there's the lid. Here's the handle coming back here. I'm not totally convinced about that, but it's close. What's nice about this photo is we can also see that there's all this dark dust in the galaxy. They call it the dust lane. So we have all this light being released by stars, but there's a lot of dust that's blocking light from stars that are further behind that. Okay, our last group of constellations are the seasonal constellations that can only be seen during certain seasons. These are not at the ecliptic and they're not near the pole. They're in between. And we can only see them in certain seasons because of our tilted axis. So when we're tilted towards them at night, we can see them. So Orion is one of the seasonal constellations. I just wanted to do that one first because it's such a well-known constellation. And like I said, I will post these notes when I'm done at the very end in case I'm going too fast for you. All right, so let's look at a couple of the seasonal constellations. Actually, this is an asterism. It's called the Summer Triangle. That should be pretty easy for you to draw. It's basically an isosceles triangle with two equal sides, more or less. And this is not a constellation. This is an asterism made of 3 different constellations. It's the brightest star in the constellation Aquila, the eagle, and that star is called Altair. Vega is the brightest star in the constellation of Lyra, the lyre, or the harp. Deneb is the brightest star in the constellation of Cygnus the swan. So together, these are easy to find, taking up a big space in the sky in the summertime. You might be able to start seeing them now, actually. Well, probably not today with the way the sky is cloudy. But here they are. The Milky Way passes through them. Now we're looking away from the galactic center. We're looking at the edge of the Milky Way beyond us. So we've got these 3 stars in the Milky Way that form the summer triangle, only visible in the summer. Here's another view, and to help you find them, it's showing where Cassiopeia is found. So here's the W, and you go to the side and we can get the summer triangle. Remember, we can also find the North Star by going in this direction. Here's a little more detail. Deneb is part of Cygnus the swan, also known as the Northern Cross. So here's the long neck of the swan, here's the wings, and Deneb is the tail. Vega is part of the lyre, a stringed musical instrument used in ancient times, like a small harp. Altair is part of Aquila the eagle, basically the head, and here's one wing reaching up here. The other wing is down below the horizon still, and the body is back in this direction. Here's another view of them. Cygnus the swan, Lyra the lyre, Aquila the eagle, with their 3 brightest stars forming the summer triangle. I just recently discovered, by looking more closely, this constellation, the dolphin, Delphinus, right next to the triangle. So because I was familiar with the triangle, I was able to start paying attention to more details around it, and I found this little constellation, which is pretty sweet. A pretty tight grouping of bright stars, pretty packed together, and making up the dolphin next to the summer triangle. Here's an artist view of them. Cygnus the swan, I think, is a pretty clear image. Lyra the lyre, maybe a little less so. Aquila the eagle, I had never seen it with a person associated with it before, but you can see the wings are stretched out here. I think of the body of the eagle coming down here. So that's the summer triangle. Now in wintertime, we have another big shape that combines multiple constellations into an asterism, and this is called the winter hexagon. And you can see it includes Orion's foot. So you're going to draw this hexagon of stars, and then I think we'll label the constellations that are included. So next to this one, you're going to label this as Orion. You're not going to draw all of Orion, just draw the hexagon. But this is that star Rigel that is a blue giant in Orion, down there at his foot. Here's the Eye of the Bull, Aldebaran, part of Taurus. So just label this one as Taurus. This one we haven't talked about at all. This is Auriga, the charioteer, the chariot driver. And the brightest star that he has is called Canopus. Over here we talked about Gemini, Castor and Pollux being the two bright stars of Gemini. Down here we briefly mentioned the little dog, Canis Minor. The star is called Procyon. And down here, the brightest star in the sky, Sirius, part of the big dog, Canis Major. So draw the 6 stars in a hexagon and just label the constellations that they're part of. Here's another view. Rigel is part of Orion, so label Orion. Taurus for this one. Auriga for this one. Gemini over here. Canis Minor here, Canis Major there. Apparently this diagram was focusing on the two dog constellations. Here's another view. This one's more like what you would actually see in the sky. This big hexagon, starting by finding Orion's belt and then expanding outward. You could find yourself Taurus. You could find the chariot driver, Auriga. You can find the twins of Gemini and then the 2 dogs. Also, Orion's belt points towards this bright star in Sirius, the bright star in Canis Major. Okay, last one we're going to look at is Pegasus and Andromeda, part of a big story of a princess that was abducted by a sea monster because the king and the queen, here's Cassiopeia, the queen, looks kind of like an M or a W, they would not pay off the gods, and so they sent for punishment this sea monster that abducted Andromeda. Fortunately, Perseus came along and saved her from the sea monster. He rode up on Pegasus, and when he arrived, this giant sea monster was there. Fortunately, Perseus had also killed Medusa. Medusa was this monster with snakes for hair, and she was so terrible that just looking at her would turn you to stone. And Perseus was able to overcome her and cut off her head by not looking directly at her. Instead, he looked at her reflection in his shield. And so he took Medusa's head and put it in a bag and flew to the rescue of Andromeda and pulled Medusa's head out of the bag to turn the sea monster to stone, rescuing Andromeda and flying off to establish their own new kingdom, or, some kind of happy ending, right? Except for Medusa and the sea monster. One thing that's cool about this constellation of Perseus is this star right here, the Eye of Medusa, is a star that's basically blinking. Although it's a rather slow cycle, it has a regular pattern of getting brighter and dimmer. It's about a 7-day, 10-day cycle, something like that. It actually increases and decreases in brightness on this known pattern. I think that's kind of cool. At any rate, Pegasus, the easiest thing to find with Pegasus is what's called the Great Square of Pegasus. And you can see we only have his body, his head, and his front legs as part of the constellation. These might be the back legs, but they're also considered Andromeda. So Pegasus and Andromeda share this corner of the Great Square of Pegasus. We could find them by finding Cassiopeia first, because she's pretty easy to find. So, got the Great Square of Pegasus. Here it is. Now it's upside down because it's a different season or a different time of day. Here's his head, front legs. You can think of these as either the back legs, or we can think of them as Andromeda. This is the Andromeda constellation. And here's her mother, Cassiopeia, the queen, nearby. Now, right here is something really interesting, and that is a galaxy. Um, it is the only galaxy that can be seen naked eye from the Earth beyond the Milky Way. Every star that you see, including the sun, including the planets, all of everything you see in the night sky is part of the Milky Way galaxy, except if you look right here, you'll be able to see the Andromeda galaxy. And it's, I don't know, many light years away. It's about the same size as our galaxy, but when we look at it here, it it looks like a little oval of light. If you look at it with binoculars, you start to see a little more than that. And if we look here, is its location. So here's this V shape of Andromeda, and here's where we can find the Andromeda galaxy. So in the wintertime in particular, you can find this galaxy, and it's the farthest that you could look away with the naked eye, farthest you could see away from the Earth naked eye. It's kind of amazing. So I hope that this has helped you, kind of been like a tour of the night sky, finding some of these different constellations, seeing some of the patterns and how the ancient people were thinking about them, how they told stories about them, um, how to navigate through the night sky for yourself. So like I said, I'm going to throw this set of notes up. If you weren't finished, you can add to yours. Otherwise, that's all I have for you for today, and you're welcome to sign off when you're done. Please submit your diagrams and notes for points, and have a great day. Well, I can still do that. Because it's just on the computer. I have to check out here. I was just reading